GCSE 9 to 1 maths. Okay, if you're aiming for a grade 7, 8, or 9, looking at a really tricky and nasty a grade 9 plus, okay, index question in roughly, okay, 5 minutes. Okay, it could be a bit longer. So question 28, we've got 2 to the x is equal to 2 to the n over the cube root of 2. We've got 2 to the y is equal to the square root of 2 all to the power of 5. Given that x plus y is equal to 8, work out the value of n. So step one, guys, is to express 2 to the x and 2 to the y, okay, as powers of 2, okay, on the right-hand side. So we're going to have 2 to the power of x is equal to 2 to the n. Now over. Now I can write the cube root of 2 as a power of 2 as 2 to the power of a third. Okay, because power of a third in maths means the cube root or the third root or the cubic root. Now, for 2 to the y, guys, what can I do here? Well, root 2, okay, the script here can be written as 2 to the power of a half. So we got 2 to the power of a half, okay, all to the power of 5. Now remember, what do I have when I've got a base to a power raised to another power, guys? What do I do here? My index laws, we times them, so it's going to be 2 to the power of a half times 5, which is going to be 5 halves or 2.5, okay? Either way would be fine, okay? So now we know straight away that y is equal to 2.5, okay, or 2.5, which is fantastic. Okay, where can I go from here? Well, I can sub this into here to work out a value for x. So if y is 2.5, we're going to have x plus 2.5 or 2.5 is equal to 8. Subtract 2.5 on both sides of my equation to balance each side respectively, guys. So minus 2.5 on both sides. When we do that, we get x is equal to 8 minus 2 is 6, minus 0.5 makes 5.5 or 5.5. So x is equal to 5.5 here, or 11 over 2, okay, as a fraction. Now, how is it going to help me? Well, to work out the value of n, now we know what, obviously, x is here. So we're going to have 2 to the power of 5.5 here, 11 halves, is equal to 2 to the n divided by 2 to the power of a third. Now, if I rearrange this to make 2 to the n the subject, okay, so if I multiply both sides of my equation by 2 to the power of a third, we're going to get 2 to the power of 11 halves, yeah, I'm going to write 11 halves, multiplied by 2 to the power of a third is equal to 2 to the power of n. Now we know when we multiply with the same base here, the base number is 2, base term is 2. We're going to add the powers, we're going to add the indices, we're going to add the exponents. So n is equal to 11 over 2 or 11 halves plus 1/3. So again, adding fractions, okay, quite an important topic. We want to have the common denominator whenever we're adding or subtracting fractions. So I'm going to obviously cross multiply. So 11 times 3 is going to be 33 plus or add 2 times 1 is going to be 2 over the product of our denominators. So 2 times 3, which will be 6. Okay, I'm now obviously going to add the numerators. So 33 plus 2 is going to be 35. So we get 35 sixths, guys, which is our final answer. Okay, of course I can write it as a mixed number. How many times does 6 go into 35? Well, it goes in 5 times fully. So 5 6 is going to be 30, with the remainder or left of it is going to be 5. So it's 5 and 5 sixths. Okay, or any equivalent fraction. Okay. But yeah, that was a tricky, I'd say, yeah. What wasn't too bad, yeah, when I went through it. Okay, but that is knowing your index laws, okay, on the back of your hand, okay, like, I know tomorrow, okay, but yeah, important, yeah, if you're unsure, remember, yeah, that if I have the square root of x, I can express that as positive x or x to the power of a half, okay, positive a half. If I have, yeah, the cube root of y, let's say, that will be y to the power of a third. Remember, if I have a negative power, that means 1 over. So if I have, let's say, 1 over y, that can be expressed as y to the negative 1 or y to the minus 1, because that negative power, yeah, remember, makes its base number or term its reciprocal, so it makes it 1 over, okay, what it otherwise would have been, or in case of a fraction, it flips it, but hopefully that makes sense. Thank you.